So now we'll look at an example here. And for this particular triangle, it says to find the length of the missing side. So first we have to see what kind of triangle is it. Well, you notice that it has the 90-degree angle box so that it is a right triangle. And with that in mind, then you have two of the legs and we're missing the length of the hypotenuse. So since we have a right triangle, we can think to use the Pythagorean theorem because we're finding a missing side length. So using that and making application here, we can figure out the missing side length. So we start by writing down the Pythagorean theorem, a squared plus b squared equals c squared. And now you can fill in the missing parts. So you can fill in 3 for a and 6 for b. Does it matter which one you put in? No, you could say 6 is a and 3 is b. It doesn't matter as long as it's the length of the legs that are going in there and that the hypotenuse goes in the c value spot. So you'll have 3 squared plus 6 squared equals x squared. And you have 9 plus 36 equals x squared. And 45 equals x squared. Now again, you're trying to find the side length. You're trying to find the length of it. So x squared is not the length. You're just trying to find the value of x. So if you remember, we can use an inverse operation that we've talked about in the past. And that is going to be the square root. The square root is the inverse operation of squaring. So we're going to go ahead and apply the square root to both sides here. And we're only going to apply the positive square root because we're talking about side lengths, and side lengths cannot be negative, so we don't have to worry about the negative solution in this case. So now this goes back to whether you remember how to simplify these radicals. In other words, simplifying square roots. So with 45, we look for the largest possible perfect square that can go into 45, and we separate it. We can also do the factor tree, if you remember. That's another way to do it. So if we do the separation here, the largest possible perfect square that goes into 45 is 9. So 9 goes in 5 times, so 9 times 5 is 45. Again, it's still all under the square root. On the right-hand side, we took the square root of x squared because it's inverse operation, so you're left with x. And now we can apply the square root to the 9, which is 3, and then you leave it as square root 5. So 3 square root 5 will be your solution to the length of the hypotenuse there. So that's the value of x. Here's another example. This time we do have the hypotenuse and we're missing the length of the leg. You can still use the Pythagorean theorem because it's a right triangle. You notice that it has the 90-degree box there. So what we can do now is make the application. A squared plus b squared equals c squared. Now in this case, s can go in for a or s could be in b. 6 could be in a or 6 could be in b. You just have to plug in one for the other and substitute it. So we can just do s squared plus 6 squared equals 10 squared. And now we're going to simplify things down. So s squared equals 36. S squared plus 36 equals 100. Subtract 36 from both sides, and you're going to get s squared equals 64. Inverse operation for squaring is the square root. Again, because we're dealing with the length of something, length is not negative, we can go ahead and take the positive square root here, which is going to be 8. So the value of that leg is going to be 8. That's the length of it. Now, even though we looked at the Pythagorean theorem, we know we can use that to determine the missing length of a triangle, a right triangle. Now we have something called the converse. The converse is actually going to basically flip things around, and it's going to help us to determine if we actually have a right triangle. So what is converse? Well, converse is when you switch your hypothesis, which is the first part of a statement, with your conclusion, which is the second part of a statement. So for example, if I said my statement was, if I drive, then I have a license, my converse flips things around. If I have a license, then I drive. And that's going to be the converse. So what we're doing now is we're trying to find how can we use the converse of the Pythagorean theorem to be able to determine if I have a right triangle. So I'm going to be given my side lengths this time, and I'm going to actually try and figure out, do I have a right triangle? So that's the application that we're going to try to make here. We already know how to find missing side lengths But if I have all the side lengths, how do I know if it's a right triangle? Okay, that's what we're going to do. So here's two examples. First one, on the left, if I'm giving you the side lengths 5, 11, and 12, and I say, well, are these side lengths going to actually form a right triangle? What we can do is we can plug them into the Pythagorean theorem and see if it actually works. If it works and it satisfies it, then you know you have a right triangle. But if it doesn't, then you don't. Now, how do we know which numbers to put where? Well, remember, the hypotenuse is the longest side, so we would pick the largest possible value that we have here, and we would set that as though it was the hypotenuse. The other two can be the legs. So a squared plus b squared equals c squared. We substitute in 5 squared plus 11 squared. Is that equal to 12 squared? Again, 12 is the largest value there, so we put that as our hypotenuse. So we go ahead and we try and work this out, and then you're going to notice that it's not going to be equal. So what does that tell you? So what it's telling me is that I cannot form a right triangle with the side lengths 5, 11, and 12. That's what it's telling me. So you can't at all. So let's try it again with the 5, 12, and 13. We can use the Pythagorean theorem, substitute the values in, simplify things down, and we get 169 equals 169. So side lengths of 5, 12, and 13 will form a right triangle. Now, just to really recap everything one more time. So the Pythagorean theorem is going to be a squared plus b squared equals c squared, and we're going to use it to find the length of a missing side in a right triangle. Okay? The converse is going to allow us to determine if we have a right triangle. So we can still use the Pythagorean theorem, but this time when you use the converse, it means you have all three side lengths and you're trying to see, will it give me a right triangle? So I hope that was helpful, and all you need to do now is just do some more practice, and I'm sure you'll be great at it.